you are out for a hike, okay? So pretend like you are out for a hike. You start, let's say you start, this is where I need, who's my artist over? This is where I need Caroline over here. So um, she would do much more justice to this picture than I am. So yeah, this is you, and you are happy, you know, you're out of Woodward, you've let your hair grow, something like that. So anyway, um, you're on a hike, okay? So you go up here, you go down here, you know, and so forth, and then, you know, this is where you decide to do your base camp, you know, for the night, something like that. Okay, so again, not, the art is not the important thing here. Okay, can you look at this, say there was a part of this journey that I was at the peak highest I was ever on this journey? Yeah, so that's pretty obvious. If you look at this point right here, this would be my maximum height or altitude. So what we would say, this is my absolute. So this point right here, this is my absolute maximum height. Okay, pretty obvious. Is there a point on this journey that looks like it is the absolute lowest part of my hike? I didn't make it quite clear. Let me make it a little bit clearer. Let's just say we started, suppose we started right here, okay? You got helicoptered in. So in this case, where would be the lowest part? It'd be this little valley right here. So this would be my absolute minimum height. So it means on that journey that you see in purple, there is no point higher than this point, and there is no point lower than this point. So this is the absolute minimum. The other one is the absolute maximum. Now, if I look at this point, say right here, okay, it is not the absolute maximum, but within that green circle, it's the maximum, right? So this point right here is the highest point of all the points inside that green circle, okay? This is not the lowest point, but it is the lowest point inside of that green circle, okay? So what we will say here is that we will say that this represents a relative maximum. And what do you think this one is over here? Yeah, that is a relative minimum. Okay? So it means that I can draw a circle around this, and I can create a space that makes this a maximum. So this is the maximum value inside that green circle, okay? This is the minimum value of all the values inside that green circle. So it is a minimum because I can construct an area where it is the lowest point. This one is the maximum for the entire graph because there is no point higher anywhere. So we got absolute maximum, absolute minimum, relative maximum, relative minimum. So all of this is going to translate to what we do with the graphs, okay? So let's look at this graph right here. So let's take a look and see. The graph that you see right here, the degree of this graph, do you know if it's even or odd? What is it? This graph. The degree. Not is it even or odd, but the degree. It's an even degree because what does a graph of an even degree polynomial look like? It looks like this or it looks like this. Which one does this look like? This looks like an even degree. The leading coefficient, I don't know what it is, but I know it's what kind of number here? It is a positive, okay? So I know that this is an even degree. It is a positive coefficient. Now, where is the absolute minimum of this graph? It's this point that you see right here. Negative 0.74, negative 7.4. Okay. That is the absolute minimum of the graph. There is no other spot on the graph that is lower, okay, on that particular one. Now, if I were to ask you, is there an absolute maximum of this graph? Can you put your finger on one point and say there is no point higher? No, why not? Keeps on going forever. So infinity is not a number. You can't say the maximum is infinity. There is no maximum here. Okay. Look at this one here. Okay. Is the degree of this even or odd? This is an even degree because they both go down. The leading coefficient, negative or positive? Negative. This graph has an absolute maximum at what point? Yeah, negative 2.47, 5.1. Is there an absolute minimum for this graph? No, there is no absolute minimum, okay? Now, I don't have the values, but so here's the absolute minimum. What would this point be? It's not an absolute maximum, but it's a what? Relative maximum. This is a what? Relative minimum, relative maximum, relative minimum. Relative just means I can construct an area where that is the lowest point. I can construct an area where that is the highest point, okay? So the big thing you need to do is first find if you have an absolute max or min, okay? Once you get those out of the way, any other max or min you see has to be what flavor? Once you find the absolutes. Once I found here's my absolute minimum, any other minimum I see has to be a what? Relative minimum, okay? So that means that this one has two relative minimums. So first determine whether or not you have an absolute max or min. Any other max or min you see has to be a relative max or min. So all we're really doing in this section is reading off of a graph. So we're not going to do, it can get very involved actually finding these max or mins. So absolute maximum, there is a point that is the lowest point on the entire graph. You can put your finger on it and you can call the number by name. Absolute maximum, same thing. You can put your finger on a number that is the highest spot in your graph. Any other max or min, it's just you can construct an area that makes that the highest point or the lowest point within that just small area. Okay? The biggest mistake that people make is they look at something like this and they say that the absolute maximum is infinity. That's not, there is no absolute value for absolute maximum for this one. Okay? So in this case, we just talked about this graph. The absolute minimum is right here. Okay, and this one, the absolute maximum is right here at negative 2.47, 5.1. So the strategy here, first find the absolute max and mins, and then anything else you see as a relative max or min. Now, what we're going to do here is put together several things we've been doing. Here's a function. What is the domain of this function? Yeah, so negative infinity to positive infinity. What is the range of this function? Yeah, so this range, so in my graphs, I think you guys have understood the graphing program I have doesn't stick arrows on it, but this goes on forever. So the y values start from negative infinity and they go to positive infinity. So the domain and range are negative infinity to infinity. Absolute maximum. Is there a spot on that graph that I can say is the absolute highest spot of the land? No. Okay, you might be tempted to pick this point. It's not the highest point because this keeps going for how long? Forever. So there is, anyway, sorry, it asked for, I was just talking about maximum. There is no absolute maximum. Same question with minimum. Is there a spot here that is the absolute lowest spot on the graph? So there is none. So there are no absolute maximums or no absolute minimums on this graph. So every other max or min that I see has to be what kind? Relative. Okay, so if you look at it, this is a relative what? Maximum. So at negative 4, 9.6, that is a relative maximum. What is this thing right here? That's a relative minimum at negative 0.8, negative 2.4. And then what is 1.5.28? Yeah, that's a relative maximum. And then what is 3.3, negative 1.8? That's a relative minimum. Okay. So not a lot of computation, not a lot of room to get partial credit. This is just looking at this and saying, I determined there were no absolute max or mins. Every other max or min, there has to be a relative max or min. Now, the other questions I'm going to ask are questions you have been asked before about this graph. How do you find the intervals where this thing is greater than 0? Okay, you've seen that before. That means I'm looking for where this graph is above the what? X-axis. So where does that happen? That happens, it looks like here, it looks like there's a piece here and a piece here. Okay? Now I need to identify these intervals. These are intervals of numbers from which axis? X or Y? X, because we only put Y intervals when we're talking about the range. We're not talking about the range. So what is this first interval that gets me from here to here? -5. Yeah. So -5 to -2. What goes around those numbers? Yeah. The 1.5.28 is this point. It's right here. This is at -2. Okay. So it goes brackets. Okay, because it was greater than equal to. Okay. What's the next interval? Yeah, 1 to 2. And then what's the next interval? 4 to infinity. Okay. So this little piece right here, from there to there, that's 1 to 2. So I'm traveling on the x-axis from -5 to -2, from 1 to 2, and from 4 to infinity. Okay. So we've done this before. We just got to bring this skill back. Okay. Intervals where this function is less than 0. That means I'm looking where? I'm looking below the axis. So that happens right here. It happens right here. And it happens right here. How many intervals did I just draw? 3. What's that first interval? I'm traveling on the x-axis. -infinity to what? Yeah, -infinity to -5. What's the next interval? -2 to 1. What's the next interval? 2 to 4. So you got to really be careful. I think careless mistakes can come into play here. Okay. So we did this earlier when we did polynomials and inequalities. Okay. So I've got that part. What are some of the other questions? I think people get to where they hate this question because there's so many parts. Where is this function increasing and where is this function decreasing? So let's look at the increasing question first. Increasing means as I travel from left to right, my graph is going what? Increasing means it's going what? Up. So as I travel from left to right, it looks like I'm going up, and I go up until I get to where? That point, and then I start to do what? I go down, okay? When do I start to go up again? From there to there, and then I start to go down. When do I go up again? There, okay? Now, I need to figure out what these intervals are for increase and decrease, okay? For increasing, this first interval is from -infinity. I increase until I get to where? Not -5, -4. It's right there. So that's, I increase until I get to that point, which is -4. I see the -4 here. So the first interval is from -infinity to -4. Okay, these are always parentheses with increase, decreasing. What's this next interval from here to here? What's that interval? -0.8 to 1.5. So -0.8 to 1.5. And then what's the next interval? 3.3 to infinity. Okay? So this one, the numbers look ugly, but you're just reading them off the graph. You're not working with these numbers and doing a lot of arithmetic, but it can get confusing, okay? People get confused about, oh, this is negative. So it's the x number that I'm worried about when I do these intervals, okay? Where is this thing decreasing, okay? It decreases. The first interval is from here to here. What is that interval on the x-axis? From here to here, it's what? -4 to -0.8. So -4 to -0.8. That's the first interval of decrease. What's the next place that it decreases. 1.5 to 3.3. That's it. Okay, so this greater than 0, less than 0, increase, decrease, that's stuff we had before. But the max and min are new, but we have to use those points to answer these questions. Okay, yes. What is the domain of this function? What's the domain? Yeah, negative infinity, positive infinity. What is the range of this function? Okay. No. Okay, so here's, guys, to find the range, I start down here. Are there any values? The first y value I see is this one. Yeah. Yeah, so it's negative 3.7 to infinity. Okay. So the first y, as I travel up that y-axis, the lowest y value that I see is this guy right here. That's the y value, negative 3.7. Yes. Yeah. What you're really doing, you're trying to say, well, the other one, the one before, it looked like this. It did. So I had y values at negative infinity and y values at positive infinity. Here, there are no y values. You know, think of it if I had like, you know, a straight edge. I'm traveling up here. I don't see y values until I get to that. That's my first y value at negative 3.7. Okay. So negative 3.7 to infinity. Now, is there an absolute minimum on this graph? Yeah, there is a number. You can put your finger on it that is the lowest spot. What is the absolute minimum? Yeah, negative 2.6, negative 3.7. Is there an absolute maximum on this graph? Answer is, I didn't hear it. No, okay. This graph goes toward infinity at the top part, so there is no absolute maximum point. So any other max or min that I see on this graph has to be what kind? Relative. Okay, so let's look at the maximums. What is this point, negative 1.5, 1.4? Yeah, that is a relative maximum. What is 0, negative 3? That's a relative minimum. And then this other point that you see right here, I actually did I not give you that one? I don't think I gave it to you. I need to correct that. I would need to give you the value of this guy. What's this one right here? That's a minimum at what, 2, 0? So 2, 0. So I'm not going to put you in a situation where you have to guess. That's what I'm doing right now. I did not label that point for you. Okay. So on the test, it would be labeled. So you're not going to have to do any kind of guesswork. We're going to say maybe it's 1.5, 1.5, and we'll say 0.75. And this is an approximation, okay? So I need to correct that. That is what page is that? 182. I need to correct graph relative max. Okay. And there's also a correction that x minus 2 is squared. Okay. So if you'll do that at the top. Okay, what are the x-intercepts? Pardon me? I'm not sure what the question is. Okay. What are the x-intercepts? Negative 3, 0. And then what? Negative 2, 0. Negative 1, 0. 1, 0. And what? 2, 0. Let me look at this. I see what you were saying, x plus 5. I've got a problem here with this. This graph must not be the exact graph that was shown there. So there is a problem with that. let's go with the graph, okay? But I see where Corey was saying, you're right, -5 should be a root of that polynomial. I've got to go fix this problem. So let's just say, I'm assuming that it's the typo and that here it's a 3. So I've got 3 different typos on this whole graph. Go ahead and correct that. So if you're ever studying back, you won't think I made it up out of the air. Huh? 1, 0 from the x right here is 1, 0. Okay. So the x-intercept -3, 0, -2, 0, -1, 0, 1, 0, and 2, 0. Okay. Is there any of those roots with a multiplicity? Which one? 2, 0. I know it's a multiplicity because my graph does not what? It doesn't cross. So that has to have a multiplicity. So I've got a multiplicity of 2 at x equal 2. And that's just the way we state that. At x equal 2, there's a multiplicity of 2. I do not cross the axis at that point. Is this thing an even degree or an odd degree? Yeah, so it's an even degree. I can even tell by looking, not only is it even, but it's 6. You can tell that by looking at the function up front. I haven't gotten there yet. I'm about to. Okay. Okay. So this is an even degree. I could tell it's 6 degree by looking at it. The y-intercept is where it crosses the y-axis. Where does it cross the y-axis? 0, -3. So that's my y-intercept at 0, -3. The y-intercept is what you get when x is equal to 0. Okay, the x-intercept is what you get when y is equal to 0. The leading coefficient of this, is it a positive number or a negative number? Positive. It goes like this, and I've got the equation to this one. So I can look at this and say, oh yeah, there's a positive coefficient in front of that. So I've got a positive coefficient. Okay. What are all the factors of this polynomial? I can read them straight from, well, first of all, this is a trivial exercise. The factors, I could copy them down from this equation. X plus 3, x plus 2, x minus 1, x minus 2, x minus 4. But if I did not give you this, if I did not give you this up here and just gave you the graph, you can see x plus 3, x plus 2, x plus 1, x minus 1, x minus 2. Those have to be factors of this polynomial. I can read it straight from the x-intercepts. So I know that the factors have to be, reading from there, x plus 3, pardon me? X plus 2, x plus 1, x minus 1, and x minus 2. Those are all the factors of that polynomial. Intervals where the function is greater than equal to 0. Okay, so what am I looking for here? Where is it above the x-axis? Okay. What's the question? The factors, okay? So in this one, if, pardon me? X minus what? Is it, did I make another mistake on this one? So I've got to go really check this one before I show it. X minus 2. Yeah, I don't know what I did. I think maybe I meant to do a graph, and I did. So there are 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, I need. Let's just go ahead and. I think what I need to do on this one is just let's just black this part out. You can do this problem, and the way you're going to see it on the test, you would not see that. Okay. Everything I'm doing, you can get from the graph. Okay, and that's what's meant to be the exercise here. Okay, when we started out in this unit, if -3 is a x-intercept or a solution, if -3 is a solution, x plus 3 has to be a factor. If -2, x plus 2, -1, x plus 1. It comes straight from knowing the roots, okay? Where is the function greater than or equal to 0? Okay, I'm looking for intervals where it lies where? Greater than or equal to 0. That means above the x-axis. That means here, here, and all of that. That's where it's greater than or equal to 0. Okay, what's that first interval? I travel from left to right. The first interval is what? -infinity to -3. So -infinity to negative 3. What goes around negative 3? A bracket, okay? The next interval. So that takes care of the first one. What's the next interval? Negative 2 to negative 1. So, okay. And the next interval. It's from 1 to 2, and then from where? 2 to infinity. Does it include the number 2? Yeah, so I can write it. I can write 1 to 2, 2 to infinity with all brackets, or I could write what? 1 to infinity, either way, okay? So I'm just going to write it's 1 to infinity, okay? That's where it's greater than 0, greater than equal to. Next question. You can see why people don't like these questions, right? It's long and it's a lot of questions. Where is it less than 0? Less than 0 is right here and right here. Okay, what is that interval? Interval. Negative 3 to negative 2 and what? Negative 3 to negative 2 and what? Negative 1 to 1. So negative 3, negative 2, negative 1 to 1. What goes around those? Yeah, negative 3, negative 1. And what was it? Negative, wait, it was negative 3 to what? Yeah, negative 3 to negative 2, sorry. Negative 3. Negative 3, negative 2, negative 1 to 1. Okay. Where is this function increasing and where is it decreasing? Okay. So let's look at this. I asked for where it was less than 0, not less than or equal to. So because I said less than, that means parentheses. Where is the function increasing or decreasing? So let's go back and look at it. So as I travel from left to right, what does it start out doing? It decreases. So it only increases from here to here, and then it does what? Decrease. And then it increases from here to here, and then it does what? Decreases, and then it increases here to here. So there are 3 intervals. What is that first interval? Negative 2.6, negative 1.5. So negative 2.6, increase and decrease is always parentheses, okay? That's the first interval. Then the next interval is from where to where? 0 to, I think we called this point 1.5. 0 to 1.5. But I would have to express, pardon me? It increases from 0 over to what this number is, which is 1.5. Well, no, it's halfway between 1 and 2 is 1.5. So from 0 to 1.5. And then where's the next increase from where to where? 2 to infinity. Okay. Intervals of decrease. Okay. So if I erase that, as I travel from left to right, I decrease from what, there to there, from there to there, and there to there. Okay. What's that first interval? Yeah. Negative infinity and a negative 2.6. And then the second interval is what? Yeah, negative 1.5 to 0. What some people are tempted to do here is they say from negative 1.5 to negative 3. What's wrong with that? Yeah, this is the x value, that's the y value. So I'm on the x-axis. It's negative 1.5 to 0, and then this next one is a what? From 1.5 to 2. Okay, so, and there we are. Okay, so this looks pretty complicated. The only thing that's new is the max and min, but all this other stuff is thrown together. Like we first started out in August, where I would ask you to do greater than 0, less than 0. Then later on, we got to increasing and decreasing. So now I'm just piling on. I've got the roots, the factors, even degree, odd degree, leading coefficient, increase, decrease, all of these things tacked on together. So this is a long problem. You'll spend a lot of time, and it's easy to make little tiny mistakes on this, but be very focused about these intervals on the x-axis. Okay, that